Hello, this is a video showcasing some of the projects I've been a part of during my undergraduate engineering studies. My name is Miguel Alanis, and I'm a recent graduate from the Aerospace Engineering Department at California State Polytechnic University in Pomona. And today I would like to discuss two of the major design projects that I was involved in during my senior year. Firstly, I was a part of a 9-member engineering team in the NASA Student Launch Rocket Competition, which required research and development of a launch vehicle and 3 engineering payloads to support future development of NASA's Space Launch System. I was selected as a lead propulsion engineer for our project, and through propulsion system trade studies and flight simulations in MATLAB, I determined the best possible combination of solid rocket motors for our 2-stage rocket to meet our desired flight profile. I also designed the propulsion system hardware that was successfully integrated with the launch vehicle. With my years of experience in rocketry, I also assisted with the general design and layout of the launch vehicle and system components. My responsibilities also included the design of a mechanical payload fairing which would house, protect, and deploy a hazard detecting camera during the trajectory's apogee. After months of design work, I helped manufacture various components of the rocket. I gained valuable experience working with composite materials such as carbon fiber to manufacture the launch vehicle's airframe and electronic base. I also used various shop tools to cut out bulkheads, rocket fins, and other components and ensured that they would successfully integrate with the vehicle. It was amazing to see components come to life like the payload fairing that I helped design. We dedicated a lot of effort in testing to assure success during mission operation. I participated in wind tunnel testing of our half-scale model and performed data reduction to produce aerodynamic characteristics of our vehicle. Static structural testing was done on the fins to guarantee that they can withstand the expected aerodynamic loads during flight. Payload fairing ejection tests were also carried out and recorded using slow motion video to analyze the entire process to confirm its functionality. We also conducted flight tests in order to demonstrate to NASA that our proposed system would meet all of their requirements. We showed that our staging system worked as planned, our engineered payload fairing successfully deployed a camera, and that all components were recoverable. It ultimately took 4 test flights, but working with a great team who was very hardworking and dedicated, we managed to pull it off. We participated in design reviews throughout the academic year with NASA engineers to demonstrate that our project was innovative and met all the requirements they had outlined. These reviews were very productive and provided real-world industry practice experience. We ultimately got the go-ahead from NASA to participate in the competition launch at the Bonneville Salt Flats in Utah. With our completed rocket ready to go, we waited anxiously for our launch.
3, 2, 1, start. There's the first red engine. Nice boost, waiting fire, goes the second. Wow!
Our hard work had paid off as we got word from NASA that we had placed 5th in the student launch competition.
Got to shoot on the booster.
During the same academic year, I also worked on a spacecraft design project with a team of 8 engineers. Working from a request for proposal from JPL, we worked to design a mission and spacecraft with the intent to analyze particle samples from the 3 regions of Saturn's rings. The proposed design from our team captured the particles using a mechanical arm and then transferred them to a sensor suite which would analyze the particles for composition and other parameters. For this system to function as planned, a spacecraft bus was designed by our team to fully support it during the mission lifespan. During this period, I gained experience in the designing spacecraft propulsion systems, power systems, telecom, attitude and control, and thermal control. I did, however, primarily focus on a certain phase of the mission which involved aerobraking. This was a mission-enabling procedure which reduces propulsion system mass by 8,000 kilograms and allowed our spacecraft to launch from the Falcon Heavy. The spacecraft would initially aerocapture into a Saturn orbit and then gradually decrease orbit size with 13 aerobraking passes. During this period, the spacecraft would experience extreme heating, and I helped design our spacecraft's heat shield that would allow our spacecraft to survive the mission phase. I determined the amount of heating we would experience during each aerobraking pass and selected the appropriate ablative material through trade studies that would protect our spacecraft. I have also been working to develop more cost-effective solid rocket motors and those commercially available to hobbyists. Using readily available materials found at local hardware stores, I have helped design and test a rocket motor that would normally cost around $100 for about 12. I have demonstrated my capacity for working on multiple design projects and creating innovative engineering solutions to complex problems. I have a passion for working on space systems and have full confidence in my engineering abilities to develop fully functional complex systems that will help achieve space exploration goals. Thank you for watching my video. I hope you have found my projects interesting.